Neurons are the fundamental units of the nervous system. The nervous system is made up of billions of neurons connected throughout the body. Neurons function through electrical impulses and communicate with other neurons through chemical signals. Neurons have three roles: to receive, integrate, and transmit information in the nervous system. There are many different types of neurons that vary in shape and size. They commonly have four structural regions that are important for communication. Dendrites are the branched extensions of a neuron. They detect the electrochemical stimulation transmitted by upstream neurons and pass the signal to the cell body. The cell body is the control center of the neuron. This is where signals from thousands of other neurons are collected and integrated. The axon is the long outgrowth of the neuron. It conducts electrical impulses away from the cell body. Axons are insulated by the myelin sheath, a fatty material that facilitates the rapid transmission of signals. Axon terminals are the small nodes at the terminations of axon branches that release chemicals, passing the signal on to neighboring neurons. Neurons come into close position with other neurons, but they do not touch. The synapse is the small space between neurons where communication occurs. Chemicals leave the axon terminals of one neuron, cross the synapse, and pass signals to the dendrites of other neurons. The term presynaptic refers to the neuron located before the synapse with respect to information flow, and the term postsynaptic refers to the neuron located after the synapse. An action potential is the neuron's electrical impulse that transmits signals to other neurons. An action potential is also referred to as firing. Neurons constantly receive thousands of signals. Any one signal has very little influence on whether a neuron will fire. Firing depends on the number and frequency of incoming signals. Some signals are inhibitory and decrease the likelihood the neuron will fire. Other signals are excitatory and increase the likelihood the neuron will fire. If the sum of signals exceeds the neuron's firing threshold, an action potential is triggered. The action potential is all or none. A neuron either fires or not. It cannot partially fire. The all or none principle means that a neuron always fires with the same intensity. The strength of stimulation is communicated instead by the frequency of firing. Every neuron has a base rate of firing. When a neuron fires at a slower frequency, that is, less often, it indicates less stimulation. When a neuron fires at a faster frequency, that is, more often, it indicates more stimulation.